Artificial satellites. Artificial satellite is a man-made object orbiting around the Earth. Artificial satellites are of two types, namely geostationary satellites and polar satellites. Let us now learn about launching of artificial satellites and different types of satellites in detail. Click on the links provided. Geostationary satellites are those satellites whose period of revolution around the Earth is equal to the period of rotation of the Earth. Geostationary satellites appear to be stationary as they revolve around the Earth from west to east. The period of revolution of the satellite is equal to the period of rotation of the Earth, and they revolve in the equatorial plane. The orbits followed by geostationary satellites are called geostationary orbits or parking orbits. The height of the geostationary orbit is approximately 36,000 kilometers above the Earth's surface. The orbital velocity of a geostationary satellite is nearly equal to 3.08 kilometers per second. Geostationary satellites are used for communication purposes. Polar satellites are the satellites which pass over the north and south poles of the Earth. Since the Earth is rotating about its axis, these satellites pass over different parts of the Earth during its revolution. They generally revolve very close to the surface of the Earth. These satellites are employed by the Army for spying and surveillance of the movements of tanks and ships and other vehicles. They are also used for weather monitoring and remote sensing. Mouse over on the underlined text for more information. Launching of a satellite. Satellites require a minimum velocity called orbital velocity in order to move around the Earth. To understand the concept of orbital velocity, let us look at this example. On the screen, a launching pad AB is shown. Let us project a body with velocity u1 from B parallel to the surface of the Earth. The body follows a parabolic path and strikes the Earth at a point r1. Now throw the object with greater velocities u2 and u3. The corresponding points where the body hits the ground are R2 and R3. R3 is a point just opposite the launching pad. With a velocity greater than U3, the body will follow a circular path instead of a parabolic path. This is the orbital velocity. For a velocity greater than the orbital velocity, the orbit becomes elliptical. On increasing the velocity, the body escapes from the Earth's pull, and this velocity is called escape velocity. Let us try to impart orbital velocity to the satellite. The required orbital velocity is imparted by using a multi-stage rocket. Now let us understand the working of a three-stage rocket. At liftoff, the exhaust gases build up an upthrust that exceeds the rocket's weight. The force of the upthrust being greater than the weight of the rocket accelerates it in the upward direction. Initially, the rocket rises vertically and passes through the denser atmosphere in no time. After the first stage burns off and falls back to the Earth, the rocket gets tilted. Now the second stage burns and the rocket attains a higher velocity. Slowly, the second stage gets detached. The final stage of the rocket tilts the satellite in the horizontal direction and gives it a proper speed of 3.01 km per second to orbit around the Earth in a closed path.